Hey everybody, this is your friendly neighborhood math teacher, Mr. Bennett. Today we're going to cover lesson 1.3, and as you can see at the top here, our learning targets. The first one, to make and interpret dot plots of quantitative data. So last time we looked at categorical, this time we're looking at quantitative data. Learning target number 2, describing the shape of a distribution. And then ultimately describing or comparing distributions. Okay, so those are the three main things we're going to look at today. We're going to do that through this lesson where we look at how many hours a week do students typically work. And so our question stems around this idea here. What is the average number of hours in a week that a senior from your state worked this year? And it says we're going to use this class as a sample. So it's not indicative of all of it, but it is a sample of high school students from our state, which is California. So you'll notice here, question 1, normally if we were in class together, I would collect all this data from you directly, but for the sake of time and for the fact that I'm recording this a couple days early, I use data from a class from last year. So if you need to pause the video to write all of this down, I know it's a bunch of numbers, but we are going to use this data. And again, each of these numbers represents the average number of hours that one student worked. So for example, this first 4 represents a student who on average in a typical week worked 4 hours a week. Okay, or this student here on average works about 12 hours a week. Okay, so that's what these numbers are referring to. Again, so if you need to pause the video, now would be a great time to do that so you can quickly write those down. And so once we have our data, we've collected our data, question 2 says go to statlit.com, our favorite website so far, and it says to use one quantitative variable single group. So I'll jump over there and show you that in just a second. We're going to enter the class data and create a dot plot. Okay, and we can just copy that down below. In this case, we'll take a screenshot. So let's jump over to Statlit. And on our Statlit website that looks something like this, we're going to go up to the data analysis section, and we're going to look for one quantitative variable single group, just kind of right here in the middle. On my screen, it's a little purple compared to the rest of the blue links. Okay, one quantitative variable single group. So if you click on that, it'll take you to a page that looks like this, in which case, again, we want to make sure we name our variable. In this case, it was the average hours worked in a week. We are going to input raw data, and we're going to type all of those in. And so you'll notice it says we can input the data separated by commas or by spaces. So this statement right here. You can put commas if you want. I just like doing spaces because I think it just saves a little time. And you're going to spend the time and type all of those in. So again, if you need a second to type all of that in, feel free to pause at any point to give yourself some time to do that. But once you have all of those typed in, you'll click Begin Analysis, which will then give you a screen that looks something like this. And so the part that we are most concerned with is the dot plot, the graph. Again, I want to point out there's this nice little summary statistics box, so we can see that there were 33 total points here, and our average number of hours was 4.36. So something just interesting to note, and eventually we'll start using that information a little bit more. But for today, we mainly just need this dot plot. Okay, so go ahead and you can screenshot that, put that into your notes. So I'll go ahead and do that for us. Back on our notes. So I'll plop that in and see if I can, oh my goodness, there we go. Oh, why can I not, there we go, sorry. So there's our dot plot. And so a couple of things we want to notice about our dot plot. First is the shape. And so when it comes to the shape of this dot plot, we probably notice right away that we have a lot of points over here to the left-hand side, right? And it kind of trickles down as we go to the right. And so what I like to do for this is I'd like to imagine this as a dinosaur. And I know that's kind of weird, but for me, it's really clear and easy to see a dinosaur. We have the head over here. We've got its big body. It's got some legs. It's got this really long tail as it comes up. Right? Boom, dinosaur. Okay, with little T-Rex arms or something. Okay, but there's our dinosaur. And so when it comes to visualizing this dinosaur, the shape of the graph always follows the tail. Okay, where is our dinosaur's tail at? And so if we notice, the tail is over here on the right-hand side. And so for this type of graph, this dot plot, we would say that this data is skewed right. And for me personally, that's always really kind of been difficult to grasp, because for me, I see a bunch of the data, right? My dinosaur body way over here on the left. So I would think that that's what that means. But when we're talking about the shape and the skew, it really has to do with the average. And where is the average value? And is that average value moving from the median? So we have two different forms of measurement. We have a median, which is just the straight middle of our data if we lined it all up in order. And we have our average, our mean. And so is that mean moving to the right? Is it basically staying in the center? Or is it moving to the left? And in this case, it's moving to the right. We'll look at that more in detail later on, but that's what it's really referring to. I just find the visual of the dinosaur to really help me keep track of what that is, because we're looking at the tail. Okay, so I know it's kind of weird, but if you can see the dinosaur, that's what I'm going with from here on out. So sorry if that looks kind of lame and nerdy to you, but I don't know, I like it. And the dinosaur looks cute. If you want, you can give him little eyes, little smile. Okay, I don't know, maybe that looks creepy. But anyway, dinosaur. Okay, so there we go. That's our tail. And something we want to be able to also determine, right, is if we're looking at this dot plot, what does one of these represent? So like if I'm looking just at one of these dots right here, what does this one single dot represent? What does this dot represent? And so in this case, it represents one student who responded. They work 4 hours per week. Okay, it only represents one student. Okay, it was their specific response of 4 hours. Same thing with something like this, right? That would be a student who responded 10 hours per week, and so on. Okay, so that's that graph. So that's our nice little dot plot there. And now question 3 says to visit this website and select the random sampler menu. Okay, so what you're going to do here is, I'll walk you through this as well. You're going to go to this website. Okay, if you click the link, it should take you straight here. You shouldn't have to type anything in. But if you click the link, it'll take you here. And so this is what we call the Census at School. Okay, it's just a group project that was put together where they interview a bunch of students and collect a bunch of data. And so what we're going to use is this section right here, the random sampler. Okay, so we're going to click on that. Up at the top, it asks us for a sample size, and we're going to select 50. Our state is California, so we're going to filter by California students. And for this, we're actually going to select all grade levels, and we're going to leave gender as all and data collection year as all. So the only things we're going to touch here is sample size to 50, California, select all grade levels, and then hit submit down here at the bottom. And it gives you two options. You can either download the data or back to the sample form. I would download it. And it's going to ask you if you want to view or download. That's up to you. I personally, because of what we're doing with it, I would just click view. and it will show up in your Safari tab here. So here's this giant spreadsheet of all this data. You notice there's a bunch of questions they ask. And the one we're looking for here, if I look up at the top, okay, here are our variables, okay, that it's up here at the top. We're looking for paid hours of work. So we're going to scroll a little ways. We see importance of recycling, importance of internet. We see birth month, favorite season, favorite school, sleep hours, communication, text messages, doing things with family, video games, watching TV, and finally, we get paid work hours. Okay, so paid work hours, this is the column we're now wanting to look at. And so what this might help you do is to write all of these down. Anything that's left blank, you can just leave blank. You don't have to write it down. Otherwise, you can put in the zeros and every other number that shows up. But what we're going to do with this is you're again going to go into Statplet, and you're going to take that list of numbers and create another dot plot. Okay, so for example, I did this other spreadsheet earlier when I was doing my example, and when I went into Statplet, I named my variable name average hours worked, and I added CA for California just so I know the difference. There's the data set that I had in that original one. You'll notice it just keeps going. There's more data sets there, or data points there, than just those. But when I begin analysis, it then gives me this dot plot. And so this is the next one I'm going to put into the notes. So if you need a couple of minutes to go through and write them all down, what I did personally was I just had this Statplet opened. And as I was going down the list, I kept going back and forth and just kept adding the numbers in here. I didn't actually write them on the paper. But whatever is easiest for you, take a couple of minutes, pause the video, do this yourself, get a random sample. So your graph is probably going to look a little different than mine, and that's okay. But you're going to practice that, find the dot plot, screenshot it, and we'll put it in our notes. So here's another good opportunity to pause and do that on your own. And then when you're ready, press play, and I'll put mine in my notes, and we can talk about the last couple of things here. So once you've screenshotted that, we'll go back to our notes, and we'll input that screenshot into our notes here. Oops. And it's kind of small, but we'll squeeze it in there. So again, we'll notice right off the bat, when it comes to the shape, right, where's all of our data? A lot of it's over here. This is my little dino. Okay, it's got a big tail this time. I don't know why. Okay, but again, the tail is down here. And the tail is the important part. Where's that tailing off to? So in this case, it is skewed right, just like our other one was. And now when we want to compare these, so question 4 says, describe similarities and differences. So I'm going to describe, that's the key word there, describe. Similarities and differences between the dot plot for the class as well as the census. And so what we're going to do here is for any time it asks you to describe at this point, you're going to use this acronym, SOCV. So we say that that's called SOCV for the V. And we always want to make sure we add context, right? And really what that means is just use words that tell me what we're talking about. Like describe it talking about hours, right? They're not just random numbers. We're talking about hours worked, okay? Students, classroom, California, just stuff like that that gives us context for what we're talking about. And when we do this, when we use this acronym, the other thing we want to keep in mind is we want to use comparative language. So I'll explain what that acronym is in just a second, but we want to use comparative language. And comparative language, right, is language where I'm directly comparing things. And so some examples of that are similar to, greater than, less than, right? Where I'm specifically saying that they are the same, right? Just describing, I'm comparing two things, saying something about them. They are similar to each other, they are the same, one is greater than the other, less than the other, and so on. Okay, now, Sakva. What is Sakva actually referring to? So the S in Sakva refers to the shape, the O refers to any outliers, the C is referring to our center, and the V is referring to variability. And as of now, for variability, you really just want to think of that as your range. Okay, there are other measures of variability, but for now, range is the biggest one. So what can we say about the shape? Well, we identified that both of them, right, using our dinosaurs. Okay, dinosaur. We identified that both of them were skewed right. Okay, so in this case, we can say something about that. Both graphs are skewed right. Do they have any outliers? Now, an outlier is typically a point that lies far outside of the data. So are there any points that look like they don't belong because they're so far from the rest of the data? So if we look at our two graphs, our first one up top, our classroom data, right, these over here are kind of far away from the rest of our data. So those might be outliers, right? I'm not entirely sure, like they're kind of close to this guy here at 14, so maybe they're far away, maybe they're not, but they look like they might be. Now this one down here definitely looks like that's pretty far, right? There's a pretty good gap in between that one and the next one. So the bottom one for sure is probably an outlier. The top ones, maybe, okay? So we can say something about that. Our classroom data might have an upper outlier. So we use upper outlier because it was on the higher end of our graph. While the state data definitely has an upper outlier. And I'm just going to drag these down to space these out a little bit. Oh, I didn't miss that. Oh, forgot the dots. Now for the centers, okay, when it comes to the center, where would we say the center of the data is? Well, if I have a lot of points over here, right, the center of my data is probably somewhere around like here-ish, because there's a bunch of points here, some there, and there's a decent amount over here. So again, we're basically just trying to find the middle ground, right? Where's the middle of my graph? We could actually count how many dots there are and figure out where that middle is, but that's kind of the general area, I would probably say. right? That 4 to 5-ish area. And over here, our middle's probably even lower than that, right? Because there are a lot more of the zeros that show up in that graph. So it's probably even a little lower. So what I would probably say about these is that even though I may not know the exact number, I can tell that this one is lower, right? It's probably closer to 1 or 2. This one's probably closer to 4 or 5. Okay, so even without putting the exact number, we can at least describe that. I can compare them. So I would say the center for the state data, state data is lower than the center for the class data. I'll just move these down a little bit more. And so lastly, for variability, also known as our range, to find this, the range, if you don't recall this from years past, our range is your maximum minus your minimum, your largest value minus your smallest value. So if I go back up to the top, if we look at our data set, looks like our largest value is 21, right? That point over here. And our lowest value is 0. There's a bunch of zeros. So our range would be our max minus our minimum, largest minus smallest, which is 21 minus 0, which would just be 21. And if I do that similarly here, for my data set, it's 26. Yours might be different. Yours might be higher or lower than that, and that's okay. But for mine, it's going to be 26, and my minimum is still going to be 0. So again, if I want to find range, it's the highest of 26 minus the lowest of 0, which is 26. So they're both pretty close, right? 21 and 26, but one is higher than the other. And so one thing I can do is I can compare that. The variability of the state data is greater than, because its number was bigger, the variability of the class data. Right? So the range was bigger for the state data, right? From 0 to 26 versus 0 to 21. And so that is how you describe. Okay, every time it asks you to describe a distribution, okay, or to describe two distributions together, this is what we use. SOCVA. Okay, it's your shape, outliers, center, and variability, which for now is your range. Okay, and I'm going to get rid of these orange here. Okay. So to wrap this all up, a little bit of notes. Learning target number 1, making and interpreting dot plots. So in making your dot plots, right, if you had to do this by hand, step 1, you want to draw and label your horizontal axis, right, your x-axis. And for this, right, remember our horizontal axis is our variable. Okay, we want to make sure that we use our variable when we label it. Step 2, we're going to scale our axis with numbers, right? What's our lowest number? And we're going to go up from there. Make sure we can go all the way up to our highest. And then 3, we're going to plot our values using equal size dots. Right? Because I don't want a dot plot that looks like this. Don't draw this, but I don't want a dot plot that looks like this, right? Because that just becomes really hard and confusing to tell. Like, is this one dot? Is that like 10 dots squished together? Like, what does that mean? So we want to try to be consistent. And I'm not expecting you to be perfect. I mean, if you want to like use, your notability tool and draw the same circle and copy and paste, you can. But, when you're drawing this, right, just try to be consistent. Whatever size dot you're drawing, just try to get close. And the other thing too is you want to try to keep the spacing the same. So if that's the amount of space, I want to try to keep that the same as I go up. Right, those are pretty close. Versus if I do this other one, right, where I have this giant space like this, like then it doesn't look clean and it's hard to look at the data. It's hard to analyze the data when it's not consistent, okay? Because there are only 3 dots in each one, but one of them looks much taller than the other, right? That tall versus that tall. Okay, so just be careful there when you're drawing these to try to be consistent with that. Then next, we have our different shapes. So what are the different shapes of our distribution? Well, for now, we have 3 of them. So I'm going to draw 3 different example graphs here. And you don't have to be perfect with these, just get the idea when you're sketching them. So when it comes to the shape, if I have a graph that looks like this, this is what we would call skewed left. Because again, right, where's a lot of my data? Oh, it's over here. So here's my dinosaur tail, right, little legs. And I don't know what happened to his face. Maybe he's a brontosaurus or something. Okay, but we notice the tail is going down here to the left. So it's skewed left. If we have a graph that's kind of the opposite, similar to what we saw today, right, something like this, again, where a bulk of our data is over here. Okay, again, the tail is now down here, so it would be more skewed right. I feel like my dinosaurs are getting less and less like a dinosaur. But hopefully you get the idea. Hopefully you can now kind of visualize it in your head like, oh, this is a tail as it comes down here. And then our last one is, well, what happens if it has kind of a tail on both sides? So a lot of the data kind of ends up in the middle here, where if I look at it, most of my data is here, and it kind of tails off in both directions. That is ultimately a good thing. Well, it's not necessarily a good or bad thing, but that is what we would call a symmetric shape. And there's more things we can do with symmetric data graphs as we'll move through the units here. Okay, but that's the idea. A symmetric is one that it starts low and gets big and then comes back low. So it's kind of split directly in half. Okay, so that's what that means. Versus our other one, right, they kind of start high and tail off. Okay, that's the big difference here. So we have 3 shapes: skewed left, skewed right, and symmetric. And then our last learning target, number 3, is when we compare distributions. And actually, I'm going to add the word describe in here. So compare/describe distributions. we use our acronym, SOCFA, plus context. And so for the shape, just see your notes above, right? We just went over that. There are 3 different shapes. For the outliers, we're looking for any values that are far from others, right? Either high or low. There could be low outliers. The C stands for center, which is your, what we'd call a typical value. And so we can use either the mean or the median. And as we go through, we'll talk about when we use which one. Okay, but your center is your typical, your standard value, kind of your average value, right in the middle. And lastly, the V is our variability. Which is how spread out our data is. Okay, and so for now, we're looking mostly at range. And this context part, right, what does it mean to add context? You're basically just, what are we talking about? Right, don't just put down a number and be like, oh, the center is 5. Like, that doesn't tell me anything about what we're looking at. I want actual context. Like, I want to know, oh, we're talking about 5 hours, or, we're looking at boys versus girls, or Sanger High versus Sanger West, or Fresno versus Clovis, whatever it is, we want to provide context to our story. Okay. So that's all I have for you in lesson 1.3. You have the rest of class to continue working on your homework assignment. So from the textbook homework assignment, so make sure you look at that. On Tuesday when I come back, I'll kind of quickly go back and recap this just to make sure if you guys have any last questions. If you guys have any questions, feel free to message me on Remind, and I will try to answer them as quickly as I can. But otherwise, I hope you guys have a great day, a great weekend, and I will see you guys soon. Make sure to like and subscribe, smash the buttons. Y'all know the drill. These ads don't pay for themselves. Just kidding. But hope you guys enjoyed, and I will see you guys later.